Analyze the reactant and product. Identify the change in the nucleus by comparing the starting isotope, thallium-207, to the power 20781 TL, to the resulting isotope, lead-207, to the power 20782 PB. Evaluate the mass number. The mass number remains constant at 207. This indicates that the total number of protons and neutrons in the nucleus has not changed. Evaluate the atomic number. The atomic number increases from 81 to 82. This means the nucleus has gained 1 proton. Identify the nuclear process. A process that maintains the same mass number while increasing the atomic number by 1 is the definition of beta particle, beta to the power negative, emission. Understand the mechanism. In beta decay, a neutron in the nucleus is converted into a proton and an electron, the beta particle. The proton remains in the nucleus, increasing the atomic number, while the electron is ejected. To the power 10 N gives to the power 11 P plus to the power 0-1 E conclusion. Because the transformation involves an increase in atomic number by 1 with no change in mass, it is accounted for by beta particle emission. The correct answer is option B, beta particle emission.